Hello everyone, my name is Siti Nurin Najwa from PEC2236D1 and today I'll be presenting my research title Stabilization of Soft Clay Soil Using Eco-Friendly Waste Materials, a Sustainable Approach for Infrastructure Foundations. In civil engineering, soil stability is super important because every building needs strong ground to stand on. But here in Malaysia, especially in lowland areas, we have a big problem. Soft clay soil is weak, holds too much water, and can lead to cracks and foundation failures. Common solutions like using cement and lime help, but they are costly and bad for the environment. So I'm exploring something greener with materials like rice husk ash, palm oil fuel ash, and fly ash. These are cheaper, eco-friendly, and easy to find in Malaysia. This study has a few clear benefits. Practically, it helps make weak clay soil stronger for construction in Malaysia. Environmentally, it's great because it uses waste materials and helps reduce the use of cement. It also adds new knowledge to the field of soil improvement, which is useful for future research. Lastly, this method supports green engineering and can guide future projects in a more sustainable way. Let's look at Pulau Pinang. Studies shows the soil have very low strength (SPT) and values of 0 to 1. It's full of water and highly porous, making it unsuitable for construction. If we don't treat this soil, we see serious problems like slope failures, cracks, and collapse conditions. And even though cement and lime are used, they can crack under uneven pressure. So we need a better and greener soil. There are many waste materials we often ignore like rice husk ash, palm oil fuel ash, and fly ash. In this study, I'm using these materials to help stabilize soft clays, and I will test them in the lab to see if they can make the soil stronger, easier to move with, and better at handling moisture. The research purposes using waste materials RHA, POFA, and fly ash to stabilize this soft clay. We'll mix them in small amounts like 5%, 10%, and 50% and test the result in the lab over 12 weeks. The goal is to see if these materials can improve the soil strength and performance compared to cement and find out which mix works best. This study is part of geotechnical engineering, which deals with soil and ground problems. It supports sustainable engineering because it promotes the use of green technology. It also aligns with Malaysia's goal for sustainable development by reducing waste and improving the construction safety. As civil engineers, we must find smart and sustainable ways to make our buildings safe. So far, I've completed a literature review studying past research on soft clay stabilization. I also looked into expert research from Malaysia and other countries. I planned the lab testing phase, which will include strength and moisture tests like the unconfined compression test and proctor compensation. From my research, I learned that soft clay is a serious problem because it can cause buildings to sink or crack. Even though cement and lime are commonly used, they don't always work well and can be harmful to the environment. That's why I'm exploring eco-friendly waste materials. They have special properties that can help make the soil stronger and more stable. Thank you for listening. I hope this project inspires more green solutions in civil engineering and makes real difference in how we build in Malaysia.